Okay, now we move to study, of course, in this section, the cost minimization problem. What actually we mean when we say the cost minimization problem. It is the problem that the firm will face when it chooses the combination of inputs in order to minimize the cost, the total cost of producing a given quantity of output. That is the cost minimization problem. And the firm that faces, this problem, that is of choosing the combination of inputs to minimize the cost of producing a given level of output, is called the cost minimization firm. The cost minimization firm. This is the firm that faces the problem of choosing the combination of inputs in order to minimize the total cost of producing a given quantity of output. Now, of course, here we have to differentiate between two important terms in economics, namely long run and short run. Of course, these two terms in economics do not refer to a specific period of time, such as, 1 year or 5 years. For instance, long run is 5 years, short run is 1 year, and so on and so forth. No, they are conceptual time periods. In economics, when economists use these terms, they think of these terms as relating to the degree to which firms faces constraints in their decision-making flexibility. So a firm will make a long-run decision, okay? A firm will make a long-run decision if it faces a blank slate. This term means, no constraints. No, it means no constraint. Okay? So a firm will make a long-run decision if it faces a blank slate, means it faces no constraints. So over the long period of time, the firm, is able to vary the quantities of all inputs as much as the firm desires. So therefore, over the long run, the firm is able to vary the inputs is therefore, as I said, over the long period of time, the firm is able to vary the quantities of all the inputs, okay, as much as the firm desires. Because what? Because the firm faces no constraints. Okay? Therefore, this is what actually is meant by the long run. When a firm faces a long run decision, it faces no constraints. So it is able to vary the quantities of the inputs as much it desires, as much as it desires. So what about, in the short run? Of course, a firm faces a short run period when it, faces some constraints. Okay? A firm faces in the short run, the firm faces some constraints. Therefore, over the short run, at least one of the inputs cannot be changed. So over the short run, the firm, of course, faces some constraints. So the firm is not able to vary all the quantities of all of the inputs. So in the short run time period, the firm, at least one of the inputs, one of the inputs, cannot be changed. Okay, now we're gonna look at, formulate the problem, the long run cost minimization problem. Okay, so here we're gonna assume that we have a firm that uses two inputs, labor and capital. Okay, labor and capital, and the prices of these inputs, the price of labor is denoted by W, wage. Of course, the price per unit of labor is W, and the price per unit of capital is R. Okay. Now remember that the price of labor, as well as the price of labor, which is W, and the price of capital, which is R, those could be either explicit or implicit. The price of labor is an explicit when the firm hires labor, okay, hires labor. And it is implicit when the firm, uses its own labor or hires its own labor, because then when the firm uses its own labor, it, of course, forgoes the opportunity, to lease that labor to another company. So that is called implicit. So when the firm uses its own labor, to run its business, then it, of course, it gives up the opportunity to gain income by, renting, its labor to another firm. And the same thing can be said about the price of capital. Can be either explicit or implicit. It is an explicit cost when the firm, hires, an outside capital. When the firm, of course, buys outside capital services, such as, using or hiring a computer. Okay, and so then the firm has to pay for, the cost of using or of hiring, from outside capital, such as a computer time. Same thing the price of capital, okay, can be implicit when the firm uses its own capital services, such as using its own computer, because the firm, will give up the lease, okay, or the renting of its own capital to another firm. Okay, that's why it's an implicit when the firm using its own capital. By doing so, the firm will, lose or give up the opportunity to gain income by leasing that, capital that it uses. Now, of course, here we say that the firm has decided to produce a given quantity of output, Q0, okay? So the firm must choose the quantity of labor and the quantity of capital, okay, that minimizes total cost. The equation of total cost is TC equal WL plus RK. So now, remember, the firm must, of course, use the combination of labor and capital to, of course, to produce a given that minimizes the total cost that to produce a given quantity of output. Now, this is the equation of total cost. So remember here, the first step in, of course, solving the long run cost minimization problem is to first draw ISO cost. Of course, from this equation of total cost, we can derive, the ISO cost. And ISO cost, of course, is the combination of labor and capital that give the same total cost. So how to derive this? Of course, you remember we have, total cost is TC equal WL plus RK. So the total cost, we have to solve this equation for K in terms of the other variables. So doing so, we come up with RK equal TC minus WL. So now divide both sides by R, we come up with this, K equal TC over R minus W over RL. So here, K, as you remember, K is drawn along the vertical axis and L is along the horizontal axis. So now for a different total cost, okay? So let's draw this total cost over here. Now in this equation, okay, in this equation of L ISO cost, as you can see, the slope is minus W over R. So in order to draw this ISO cost, of course, we have to, of course, indicate or find the K-axis intercept and the L-axis intercept. Remember, for y-axis plane, we have y-intercept and we have x-intercept. Here, since K is along the vertical axis, then we have to look for the K-axis intercept and for the L-intercept, for the L-axis intercept. So to draw this one, we come up with this here. So this is K over here in the vertical axis, and this is L along the vertical axis. So I want to draw for different, total cost. Let's say for different total cost. TC, let's say 2 greater than TC1 greater than TC0. So we have different total cost. So what we're gonna see here, as you can see, as you move, northeast, north, of course, northeast, total cost, of course, the ISO cost will, become bigger, okay? So drawing the ISO cost for TC0, the lowest, total cost, okay, the K-axis intercept is going to be equal TC over W, TC0 over W. Now, as far as the L-axis intercept is going to be equal, of course, L TC0 over W over R here, sorry, over R. So in order to find the k-axis intercept, we just divide the total cost, okay? For this case, for total cost TC0, we divide TC0 over the, of course, the capital, the price of capital, the unit capital is W, is R. So we divide TC0 over R. And to get the L-axis intercept, we divide the total cost over the price of labor, which is W. So TC0 over W. We connect those, and this is, the total cost, the first one. The second total cost is the same thing, of course, which is TC1 over W, over R, sorry. We divide the k-axis intercept over the price of capital, which is R, okay? So TC1 over R, and over here the same thing, of course, TC1 over W. We divide the L-axis intercept by the price of labor, and we connect those, and we come up with the second, isocost. First isocost, second isocost, the same thing for the third one. TC3 over R over TC3 over W. So then what we do here, we draw three isocosts. Remember that they have the same, slope, W or slope. They have the same slope, which is minus W over R. So that's why we have three parallel isocosts, because they have the same slopes, and this is how we derive the isocost lines. Of course, as you can see here, the first step in solving this problem, the long run cost minimization problem, is to first draw the isocost lines, of course, and then, of course, later on, of course, then we draw the isoquant. Okay, the next step is to draw the isoquant. Okay. Now we're going to, of course, have a solution of the long run cost minimization problem. We're going to do that graphically. Okay, so now we're going to use a graph to solve the long run cost minimization problem. Okay, now here we have a graph, of course. As you can see, we have two isocost lines, each correspond to a different total cost, of course, and we have an isoquant. Remember, an isoquant is, a curve that shows all the combinations of labor and capital that give or that yield a given level of output. Now here, Q0. And isocost, of course, is the combination of labor and capital that, give, a certain level of total cost. Okay? Great. So you have two isocost lines and one isoquant. Now, as you can see, the solution here is attained at point A. Okay, is attained at point A. Okay, at point A, as you can see, the isoquant is tangent to the isocost. Okay, the lower isocost here that correspond to total cost TC0. So at point A is the optimal, point of solution for this kind of problem at point A, where the firm, of course, uses, that amount of, labor and that amount of capital. Okay? Now, the question is that why not the solution, the optimal solution at point K, or at point B, or at point C? Now, as you can see, K is a point that is off the isoquant. Okay? The firm could produce at K, But then what is the cost for the firm? You know, it could produce at K, but it's going to what? Use higher, levels, okay, of labor and capital. However, the firm is able to produce Q0 by using fewer levels of labor and capital. So why not produce at K? So producing at K is very inefficient. Now what about B and C? You know, the same thing, producing at B, as you can see, B is on a higher ISO cost. You know, this ISO cost corresponds to higher total cost, okay? And at C, you know, this point C is on a higher ISO cost, which corresponds to a higher total cost. So B and C also, even though they are technically efficient because they are along the isoquant, however, you know, they don't give the optimal combination of labor and capital that give, you know, the solution of the long-run cost minimization problem. Okay, so point B is the one that is optimal, okay, where we can get, because the whole objective of the firm is to, produce Q0 at, and minimize the cost, okay, minimize the cost. So only at point A the firm is able to minimize the cost. Now, also here we could prove in a second, once we go through the derivation of the formulas, mathematically, as you can see at point A that we have just shown that it is the optimal point. At point A, as you can see, it's a point of tangency between the isoquant and the lower iso cost. Okay? Now, what that means? It means that the slope of the iso cost is equal to the slope of the isoquant. Well, the slope of the iso cost, as we said, is what? Minus W over R. What about the slope of the isoquant? Remember, slope of the isoquant is what? Is minus slope of isoquants minus delta K over delta, L. Okay? That's the slope of the isoquant. And that is, the negative of the slope of the isoquant is the marginal rate of technical substitution, as you can see over here. Okay? So, the negative of this is going to be the marginal rate of technical substitution. So, the marginal rate of technical substitution, which is equal to what? The ratio of the marginal productivities of labor and capital. So as you can see here. So now, the slope of the isoquant is equal to the slope of the isocost. We put them over here. So you get minus PL over minus MBK equal minus W over R. Slope of the isoquant equal to the slope, the negative of the slope of the, of course, or the, the slope of the isoquant is equal to the slope of the isocost. And so what we get over here, taking away the negative sign, we get the ratio of the marginal product of labor to the marginal product of capital is equal to the ratio of wage rate over, R, W over R. So here, as you can see, the ratio of marginal products is equal to the ratio of the input prices. Now, of course, we could write this optimality condition in the following form, okay? It becomes, a marginal product of labor over W equal marginal product of capital over R. Now, if I use these formulas, to show that, point B and C are not optimal, because as you can see, at point B, the slope of the isoquant is higher than the slope of, the isocost, So they are not equal. The slope of the isoquant at point B is not equal to the slope of because the slope of the isoquant at point B in absolute value is higher than the slope of the isocost at point B. Okay? So they are here, because they are not equal, then it does not give us the optimality condition. The same thing can be said about point C. Okay? Point C. The slope of the, one of them is higher than the slope of the other in absolute value, and that's why we cannot have optimality condition at point C. So the only optimal point is at point A, where the slope of the isoquant is equal to the slope of the isocos. So now, as you can say here, the optimal on-bit combination at A is an interior optimum. What that means? An interior optimum involves positive quantities of both inputs. That means at point A, we're going to, use positive levels of labor and positive level of capital, okay? And that's called, interior optimum. Now, what does condition 2 tell us, okay? Condition 2 tells us that at a cost minimizing input combination at point A here, the additional output, okay, per dollar spent on labor services is equal to the additional output, of course, per dollar spent on capital services. This is what it means, this condition 2, that is derived from condition 1 over here.